Welcome, ladies and gentlemen, to Warwick Science's Film Practical, which is looking at weathering. Now, we have two types of weathering that occurs. One is called physical weathering, which is the breaking down of the rock through things like weather, ice, wind, snow, and the like. And there's chemical weathering. So I'm going to show you both of them today. Again, there'll be a write-up which comes up in a moment. Can you please stop the video, copy it down, and then unpause the video when you are ready to go. Now, the first one that we're going to be looking at is physical weathering. It's also called mechanical weathering, and to do that I'm going to need to use the Bunsen burner there. Now, in order to show this, what I'm going to use first to show you the effect is in fact a piece of glass rod. Okay, just as simple. Now, this can replicate and simulate the rock. Now, let's put that on to high. Here, I have a beaker of cold water, and its job there is to basically to cool the rock down really quickly. So, by doing this, what I'm doing is I'm actually heating the rock up. Of course, when you heat anything up, it expands it a small amount. Okay, so this is getting a little bit bigger with each time. You can see now around the end there, the flame's starting to go a little bit on the yellow colour. I'll do this for about 2 odd minutes, and then what I will do is I'll actually plunge the piece of glass rod into the beaker. Now, it's got a really lot of heat on there. Beautiful, then plunge it in, and you can hear there the effect that when I plunged it into water that it had. Okay, now taking it out. Okay, and again, if you ever do this, you should never ever reheat the same piece of glass again, but if you look at it closely now, you'll notice that it's basically shattered. Okay, and what happens is that the heat expands the rock, or in this case the glass, and you end up and you can break it. It gets cooled, shrinks down, and you can break it really easily. So that's what we call physical or mechanical weathering, and ice can do it, rain, temperature, whole sort of materials can get that done. The next one is looking at chemical weathering, and to chemical weather, what I'm going to use is some basic limestone in this case, and some igneous rock, that being granite, and that's what we call blue metal, but we call it granite. Now, if we heated the granite up and plunged it into the water, we would have found the same thing as well. Now, here I have some 2 molar hydrochloric acid, and we use acid because we have a substance on our earth called acid rain. And what happens is anything that produces carbon dioxide gas, which is CO2, it goes up, mixes with water in the atmosphere, and forms a substance called carbonic acid, which is the same stuff that's in Coca-Cola. Then that comes back down to the earth and is slightly acidic, so it has some effects there. Now, what I'll do is I'll bring it up nice and close and put some on, and you can see straight away that we've got a bubbling occurring, and that tells us that a chemical reaction is happening, and something's going on there. And what's actually going on is the calcium carbonate that's present in the rock is basically dissolving and reacting with acid, and it's forming well, 3 things: water, salt, but also carbon dioxide gas. So what will happen is if you leave this overnight, extended period of time, that rock will then start to break away. Okay, and you can't see, but I can actually see small sediments of rock material as opposed to calcium carbonate actually just dropping off from the rock. So limestone does that. Now, sandstone and mudstone don't. and they don't react with an acid. And I've got this piece of sandstone from the last one that I had a look at. Okay, and if I put it on here, okay, just simply looks like it's wet. Okay, and it doesn't react, and it doesn't react simply because there's no calcium carbonate in there. There's nothing for the acid to react with, so it doesn't react. Now, if I've got this one here, I'll look at this one, and what I've got is, of my last one, is a granite. Okay, so again, now this is 2 molar hydrochloric acid, so it's pretty concentrated. I place that on, and again, nothing is happening there. Okay, it's simply just made a wet rock, and that's because, again, there's no calcium carbonate that's in an igneous rock, so the igneous rock does not react with water or with acid in this case. Now, in terms of chemical weathering, only sedimentary rock or rock that contains calcium carbonate will chemically weather. In terms of mechanical weathering or physical weathering, all of the 3 rock types will engage in that. So again, if I came back tomorrow with the limestone, or I put some sandstone in water or some mudstone in water, there'll be little bits that would have just broken off. Okay, and that's due to the fact that water particles are moving inside the liquid, so they just bash up against the rock and little bits break off. Obviously, it takes granite a lot more time, and it takes metamorphic rock a lot more time because it's a lot harder for that to happen. Okay, so that's the 2 types of weathering that we have. We've got physical weathering, which is breaking down using mechanical means, so things like weather, things like ice, snow, cold and hot temperatures, and the like. And we have chemical weathering, which is where the acid is reacting with the calcium carbonate inside the rock. If you'd like to fill in your prac write-up that you did earlier, and if you have any concerns, please go and check it out with your teacher and make sure that everything is up to scratch. And thank you for accessing Warwick Science's Film Practical on weathering and erosion.